Alright, this question deals with an elastic potential sniper rifle. Now I'm going to show you a demonstration on how this sniper rifle works, and I'll show you the experiment I did to get this data that you see here on the board. So go ahead, take a look at that. Trial 1. Loading the gun carefully. Now I'm going to stretch the elastic 13.5 centimeters. There we have our first result. Trial 2. Carefully load my gun, stretch my elastic to the same point. There we have our second result. As you can see, our two trials very close together. And we'll take a precise measurement of the height. And the mass of the projectile reads 0.87 grams. Alright, so now we have to answer some questions about this, like what is the constant for our elastic here? What is the spring constant K? Now, in order to do that, we need to go back to kinematics. We need to look at what's happening horizontally and what's happening vertically. First, you're going to want to look at the vertical direction. Now, that projectile is released at a horizontal angle, meaning it has an initial velocity in the vertical direction of 0. Using that and knowing our acceleration and the distance it traveled vertically, we can calculate the time it took to fall. Once we have that time, it's important to note that the time it takes to fall is the same as the time it has to travel in the horizontal direction. So knowing this time, we can plug it in over here in our horizontal direction and solve for our velocity here. So this is what we want to find. Once we have this, it's now time to look at the energy portion of our equations. Now the energy of a spring, the elastic potential energy, is equal to 1/2 kx squared. Remember, we're trying to find K. Now all that energy stored as elastic energy, once the elastic's released, it's going to be converted into kinetic energy. Now we've just found our velocity. We have the mass as given in the question, and we have our equation. So if we equate these two, we can indeed solve for our unknown. Good luck, have fun.